Hello. Okay, 8 unit circles. Here we go. So there are three types of segment lengths that are formed by intersecting lines or segments, or in this case, type 1 would be intersecting chords or secants inside the circle. Type 2 would be intersecting secants where they intersect outside the circle. And type 3 would be an intersecting tangent with an intersecting secant. So we're going to talk about all three of these one at a time. Here we go. First one, type 1, intersecting chords. Basically what we're doing is we're taking a little piece of one chord called A, a little piece of the same chord, the other piece, call it B, a piece of the other chord, C, the other piece of the other chord, call it D. And there's a certain relationship between them, which is really cool. It's going to be A times B. So this part times this part equals this part times this part, C times D. That's cool. So we're going to do an example right now to show you what that means. So say, for example, we have 14. We'll call that A, and 15, B, 10, C, X, D. So we get A times B, 14 times 15, C times D, 10 times X, and we solve. That's going to give us 210 equals 10X, X equals 21. There we go. That's an example. We're going to do all the even at the end, but I'm going to give you an example for each as we go, and then we'll go through them all. So type 2, here we go. This is if it intersects outside the circle, and it's two secants intersecting outside the circle. So we have this guy and this guy. What's cool is if we take just the little piece that's outside the circle, we'll call that C, and we multiply it by the whole thing. The whole thing is not D, it's C plus D. That's going to equal the outside of the other side, A, times that whole thing, A plus B. That's cool. That is going to be what I'm going to show you now. So say, for example, number 6, we have the outside here. We have two intersecting secants. Outside, that's 13, times the whole thing. That's X plus 13. That's going to equal the outside, 10, times the whole thing, 52. Cool. So distribute, we get 13x plus 169. 10 times 52 is going to be 520. And then we solve for x. 13x equals 351, x equals 27. But we're not done. We need to find NL. So we know NL equals x plus 13, and we just found x. So we know it's going to be 27 plus 13, which is 40. Now we're done. Cool. So that is type 2. Type 3 is basically the same as type 2, except a little bit different. So we have a secant and a tangent. So it's going to be the outside here, B, times the whole thing, times the whole thing. And it's going to be the same thing for the tangent. It's going to be the outside times the whole thing, except the whole thing is A again. So instead of writing A times A, we can write A squared. That's not 9. A squared. So let's do an example of that. How about number 10? So number 10, we have the outside here, 8. Whoops. Times the whole thing. That's going to be 8 plus 5x minus 1. And that's going to equal the other side, 16, times the whole thing, which is 16. And let's do in the parentheses. We get 7 plus 5x equals, make sure you put in parentheses, guys, or you're going to get lost here. All right, so this is going to equal 256. So we get 56 plus 40x equals 256. 40x equals 200. X equals 5. Nice, except we're looking for Pn. Pn is this. Let's see if we get a different color. Pn is this, just this part. And we know that to be 5x minus 1. So we're doing 5 times 5 minus 1, which equals 24. Cool. All right, so those are all three types. And now I'm going to do all the even. So here we go. This is going to be the first type. Two intersecting secants in the circle. So we get 6 times 6 equals 4. Make sure you put parentheses because it's not going to be 4 times 5x minus 1. That would be 20x minus 1. So we get 36 equals 20x minus 4. So I get 40 equals 20x, x equals 2. And since we're looking for BD, we know BD equals 4 plus 5x minus 1, which equals 4 plus 5 times 2 minus 1, which equals 14 minus 1, which equals 13. Ooh, 13. There we go. Number 4, same thing. We have intersecting secants in the circle. So we get 2x minus 5, parentheses, 18, 14, 2x plus 1. Okay, so let's distribute. We get 36x minus, what's 18 times 5? Gotta do this in your heads. 90. 28x plus 14 when we distribute. So we get 8x equals 104. So x equals 13. And we're looking for TQ. TQ is 2x plus 1. So 2 times 13 plus 1 equals 27. Nice. 6 we just did. 8. 8 is going to be an example of two intersecting secants outside the circle. So we need to take the outside part here, 12, and multiply it by the whole thing, which is 12 plus x plus 8. And that's going to equal the other side, which is 15, times the whole thing, which is 15 plus x minus 1. So simplify the center, we get 20 plus x. This is going to be 15 times 14 plus x. So this is going to be 240 plus 12x equals 15 times 14. That's going to be, what is 15 times 14? 15 times 14. 15 times 14. Ding, 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 ding. 15 times 14 is 210. 210. 210 plus 15x. I just distributed. So get everything on both sides. We get 3x equals 30. X equals 10. And we're looking for yz. We know yz is equal to x minus 1. So 10 minus 1 equals 9. There we go. 10 we did, so let's do these 3 and we're good. All right, so this is going to be a secant and a tangent. So the tangent is going to be 3x times the whole thing, which is 3x, so we just square it. And then we get the outside, 9, times the whole thing, which is 25. So this gives us 9x squared, and this gives us 175? Yes. 225. So 8 would be 200, 225. So x squared gives us 25. X gives us, after we take the square root, plus or minus 5. And so x could equal 5 or negative 5. But what is 3 times negative 5? Negative 15. Can we have a distance of negative 15? No. So our real answer is x equals 5. And we're just solving for x. So we are done with that. Next. All right. So this is going to be a secant and a secant again. Outside the circle. So we're going to get 4 times the whole thing. 6 equals outside x times the whole thing. X plus 5. right? The whole thing is x plus 5. So this is going to be why we did the algebra part. So let's see. So we get 24 equals x squared plus 5x. So now we have an x squared and a 5x. So we can't just solve. We're going to have to get it set it equal to 0 to be able to do this. All right, so now we need to factor. We need this into multiplication so we can actually solve this. So we get two numbers that multiply to give us negative 24 and add to give us 5, positive 5. So I can see it right away. We have an 8 and a 3, so we need the positive 8 and negative 3. That will give us positive 5, so we get x plus 8, x minus 3. And so we set each equal to 0. Let's show you that again. Set each equal to 0, so we get x plus 8 equals 0 and x minus 3 equals 0. So x equals negative 8 and x equals 3. We can't have a negative 8, so our answer is x equals 3. There we go. Glad we did the algebra review, I suppose. And here we go again. Last one, a tangent. So we take this side and square it, and it's going to equal to the outside, 12 times the whole thing, 27. So this is going to give us 12 times 27 is 324. Now, here's the trick. I don't know if you remember, but when we're squaring a binomial, we square the first, square the last, multiply these together, and double. So 5 times x is 5x, double is 10x. Now we need it all on one side. X squared plus 10x minus 299 equals 0. Wow. So we could always use the quadratic formula if you remember it, but there is a factor here. It's going to be two numbers that multiply to give us negative 299 and add to 10. And I see them as negative 23 and, 23 and 13. Yeah, there we go. 23 and 13. This one must be positive for us to get it to a positive 10. So we get x plus 23, x minus 13 equals 0. Set each equal to 0. Because we can divide the other over and get 0. I showed you how to do that. So x could equal negative 23 and x could equal 13. So both are answers, but we have to see in the context of the problem, does each make sense? So if I plugged it in here, can we have a negative length? Negative 23 plus 5 is negative. So no. Let's see that. Ooh. 13 we can. So 13 is our answer. All right, guys.